Hello everyone, today I will be showing you how to solve radical equations. A radical equation is an equation that contains a radical of some sort. It may be a square root, it may be a cubed root, fourth root, fifth root, and so on. The idea behind solving radical equations is first to isolate that radical and then apply the exponent to both sides of the equation that matches the index of the root. So here are just a few examples of radical equations. Some of them have square roots, like my first two examples, and some of them have cubed roots, like my other two, my third and fourth problems here. So remember, to solve a radical equation, you first have to get the radical by itself on one of the sides of the equal sign. If you look at this first example here, you notice that the square root of v is already by itself on the left hand side of the equal sign. There is nothing else on the same side of the equal sign, which means what we need to do, what's left for us to do, is to apply the exponent to each side of the equation that matches the index of the root. The index of this root is 2. By default, if you're missing the index, it's a square root. So all we do is we apply a square to each side of the equal sign to remove the square root. Because remember, the square root and the square, they cancel each other out. So here's what we now have. On the left side, it used to be a square root of v, but then we squared it, so now it is just the v. And then on the other side, it's 3 squared, which is a 9. And that's it. So v equals 9. You can always check, and you always should check your work by plugging this answer back into the equation. The original problem was square root of v equals 3. So if you replace v with the 9, which was our answer, you get square root of 9 equals 3, and that's true, it checks. So now let's look at problem number 2 here. In the second problem, your square root is not by itself on the left side of the equal sign. It actually has two things that stop it from being by itself. Specifically, you have this minus 8 that's on the same side as your square root, and you also have this 2 that's on the same side as your square root, but it's not under the square root. So you first need to remove those two things. So first I'm going to remove the negative 8, and to do that I will do the opposite of what I see, and I see subtraction, minus 8. So when I place it on the other side, I'm going to make it plus 8. And that gives me the square root of 2, still here, we didn't touch that, u plus 8. Minus 8 is not here anymore, equals, and now it's a 10 on the right side. At this point, the only thing that's left for us to get rid of is this 2. So this 2 is attached to my radical by multiplication. To remove it, I need to do the opposite, which is division. So I'm going to divide both sides by 2. So now I have square root of u plus 8, that is equal to 5. At this point, I'm ready to do the same thing I did with my first problem, which was square each side to remove the radical. So that's what I'm going to do, because the root is now by itself. There's nothing else on the same side as my radical. So I'm going to square the left side, I'm going to square the right side. On the left side, the whole point of squaring is to remove the radical is gone, and what you have is u plus 8. On the right side, you have 5 squared, which is 25. Well, now I need to get my u by itself, because that's the whole point of solving the equation, and to get u by itself, I need to remove the 8. It's a plus 8 on the left, so I minus it from 25. So I get u equals 25 minus 8, which is 17. Then we will check this work. So to check this work, I'm going to plug the 17 back into my original problem, and we're going to have, so remember the original problem is right here in black. It was 2 square root of u plus 8. My u is 17, so I'm going to write 17 plus 8. Minus 8, this minus 8 right here, equals 2. And now all we need to check is if the left side is actually equal to the right side. So on the left here, I have, first I'm going to do the radical. 17 plus 8 is 25. So 2 times the square root of 25, and then minus 8. We assume it's equal to 2. We need to check that. So square root of 25 is 5. 2 times 5 is 10, 10 minus 8 is 2, so it works. The answer is 17. So now let's look at this problem. It also is a radical equation, but the root here is cubed root, not a square root. The idea, however, is exactly the same. You have to first get the radical by itself, and it is by itself since there is nothing that is around my radical here. And once it's by itself, we need to apply the exponent that matches the index of the root to each side of the equation. So this index is 3, which means we have to cube each side of the equation. I'm going to cube the left side, cube the right side. On the left now, the cube and the cubed root here cancel each other out, leaving you with 4x minus 1 only. And then on the right side, you have to cube the negative 5. So you're going to do negative 5 times negative 5 times negative 5, which will be negative 125. Well, this step helps us remove the radical, the cubed root, but now we have to get x by itself, which is the whole point of solving the equation, of finding out what x is equal to. So here I need to do two things to get my x by itself. First of all, remove this minus 1. Since it's minus 1, I'm going to place it to the right side and make it a plus 1. Now this equation is 4x equals negative 125 plus 1 is negative 124. And then I'm going to divide each side by 4 to get the x by itself completely. So divide both sides by 4. And you're going to have x equals negative 124 divided by 4. That is negative 31. And this is the answer. Again, let's go ahead and check this work. So to check this work, I'm going to use my answer that I just got for x, which is negative 31, and plug it into the original problem before I did any sort of changes to it. So to check, I'm going to write cubed root of, it used to be 4x minus 1, but now I know x is negative 31. So 4 times negative 31 minus 1, that's under the root, and then on the other side I had negative 5. So we need to check if the answer on the left, is the simplified form of the left side is actually negative 5. So 4 times negative 31 is negative, right here, negative 124. Then we minus the 1 from it, it's negative 125. So cubed root of negative 125, is that a negative 5? The answer is yes. If you cube root the negative 125, you get negative 5. So negative 31 is your answer. Okay, so let's look at this example here. It's a square root equation. You have a square root of negative 20 plus 7w on the left and a w minus 2 on the right. The nice thing about this equation is the square root is by itself, which means you don't have to remove things to the other side before you're ready to square it. So I am ready to square it, so I'm going to go ahead and apply the power of 2 to the left side and to the right side. Remember, the whole idea is to remove the radical, so we're trying to match the exponent that we apply to each side of the equation with the index of the radical, and that's a square root here. So we're going to apply the 2 here, and notice I'm going to square each, the whole thing on the right side, each side, and on the right side I have w minus 2, so I'm squaring the entire w minus 2. So on the left, it's very simple. The square root and square cancel each other out, leaving you with negative 20 plus 7w. On the right side, the common error that I see students make is to say that this is w squared minus 4, when it's not. W minus 2 squared means nothing but w minus 2 times another w minus 2. And that is foiling. So you do have to go through the foiling procedure here to figure out what w minus 2 squared is. So I'm going to leave the left side as is, plus 7w here, and then on the right I have to do w times w times negative 2, and then negative 2 times w, negative 2 times negative 2. So that's going to be w squared minus 2w minus another 2w plus 4. So this is what I now have, and if you notice, one of the terms in this equation is w squared. What it means is that it's not a linear equation anymore, it's now a quadratic equation. To solve a quadratic equation, I need to consolidate all the terms on one side of the equal sign, make sure the zero is on the other side, and then solve using factoring if possible. So I'm going to do the following. First of all, I will combine this negative 2w and this negative 2w into a negative 4w. They're like terms. So here's what I now have. Negative 20 plus 7w equals w squared minus 4w plus 4. At this point, I'm ready to move all things to one side of the equal sign. It doesn't matter which side you pick. You can choose to move them to the right side or to the left side. Since I have w squared already on the right side and 3 terms on the right and only 2 on the left, so I'm going to take the left side and move it to the right side. So to do that, I'm going to take my negative 20, and since it's negative, I'm going to make it positive here. I will be adding it. Specifically, I will be adding it to this 4 because they like terms, so it's not here anymore. And then plus 7w, I'm going to be subtracting since it's positive, and specifically, I'll be subtracting it from the negative 4w here. So here's what I have now. On the left side, I have a 0, and on the right side, I have w squared. These two, negative 4w, negative 7w, will give me negative 11w. And then 4 and 20 together is at 24. So it looks like this is a quadratic equation that probably can be solved using factoring. So all I need to do is find two numbers that multiply to positive 24, but at the same time add to negative 11. Those numbers are negative 8, and negative 3. If you multiply negative 8 and negative 3, negative 8 times negative 3 is positive 24. If you add them, you get a negative 11. So the factored form of the trinomial on the right is w minus 8 and w minus 3. I just use these two numbers and place them here with parentheses next to w, and remember that it equals to 0. So at this point, all we need to do to solve for w is to take each of the factors. The first factor is w minus 8, and the second factor is w minus 3, and set each equal to 0. So you have w minus 8 equals 0, which means w equals 8. And then you also have w minus 3 equals 0, which means w is 3. These are the two answers that we must check. So to check, I will take the original problem. I'm going to replace w's, each w, first with 8, and then the second time with 3, and see if the left side is actually equal to the right side. So let's replace each w with an 8 now. That means we have negative 20 plus 7 times 8 equals 8 minus 2. So here under the radical you have 7 times 8, which is 56. And 56 minus 20 is 36. So square root of 36 equals 6. Is this true? Yes, square root of 36 is in fact a 6. So now I'm going to, so 8 works. 8 is my answer. Now I'm going to check the 3. The square root of negative 20 plus 7 times 3, remember w is now a 3, equals 3 minus 2. So here on the radical, I have 7 times 3, which is 21. 21 minus 20 is 1, so square root of 1 equals 3 minus 2 is 1. Square root of 1 is actually 1, so 3 is also our answer. It worked. So with this problem here, you notice that you have two separate square roots. You have square root of y minus 13 and a square root of y. To get rid of the square root, we square. But the condition for that is the square root must be by itself. If the square root is not by itself, you have to remove things, move them to the other side of the equal sign, and after that you square each side. So here you have two square roots, they're separate. You can't remove them at once. You have to remove them one at a time. So for that, I'm going to first get this larger square root by itself. So to do that, I'm going to take the square root of y and put it on the other side. So I'm going to take this positive square root of y, place it here, and make it negative square root of y. At this point, here's what I have. Square root of y minus 13 equals 13 minus square root of y. Now we're ready to square each side with the purpose of removing the radical. So I'm going to square the left side. And I'm going to square the entire right side. And remember, just like with previous example, this is going to have to be foiling. It's not squaring 13 and squaring a square root of y separately. So the left side is easy, square root and square cancel each other out, leaving you with y minus 13. On the right side, you have to say 13 minus square root of y times 13 minus square root of y. Okay, well, let's go ahead and FOIL the right side. First, we're going to do 13 times 13, which is 169. Then you're going to do 13 times negative square root of y, which is negative 13 square root of y. Then you're going to do negative square root of y times 13, which is another negative 13 square root of y. And then finally, negative square root of y and another negative square root of y will give you a positive square root of y, since you're multiplying basically by itself, squared. And you still have your y minus 13 on the left side. Okay, well, let's see what we have here. First of all, I noticed that I have a square root of y that has a square applied to it. So this becomes a regular y without the square root and without the square, because square and square cancel each other out. It's positive. Additionally, you have two of identical radicals with a negative 13 in front of each. So what you're allowed to do is you're allowed to combine the negative 13s to a negative 26, with the square root of y following. Then I'm going to bring down my 169, and then y minus 13. Okay. Well, at this point, I ended up with another radical equation. I still have a radical here, and remember, to solve a radical equation, you have to get that radical by itself and then apply the exponent that matches the index of the radical. So I want to do just that. I'm going to isolate my radical y, get it by itself. I'm going to remove one thing at a time. So first of all, I'm going to move 169. It's a positive 169. I'm going to put it here, make it negative 169. So it's gone. This is a positive y. I'm going to place it here and make it a negative y. Notice I'm placing them under the like terms so that I can combine them eventually. So let's see what's going on here. These cancel. Y minus y is gone. Negative 13 and negative 169 together are going to be negative 182. And on the right side, you have negative 26 square root of y. Well, we're almost done with getting that y, radical y by itself. The only thing that stops us is the negative 26. To remove it, we need to ask ourselves, how is it attached to my radical? And it's attached by multiplication. So I'm going to divide, we'll do the opposite of what I see, divide both sides by the negative 26. Negative 1h2 divided by negative 26 is 7, positive. So now we have square root of y equals 7. So at this point, I am ready to finally square each side to get my y by itself. I'm going to square the right side and square the left side. So square here and square here. So on the right side, you will get just a y, and on the left side, you have 49. So y equals 49. And then we don't forget to check. So I'm going to replace this y with 49 and this y with 49 and see if the left side is actually a 13. So here we go. Square root of 49 minus 13 plus square root of 49 equals 13. So 49 minus 13 under this root is 36. So square root of 36 plus square root of 49 equals 13. Square root of 36 is 6, square root of 49 is 7, 6 plus 7 is in fact 13. So my answer, 49, worked, and that means that that's my answer. And this last final example is the square root of x plus 4 equals negative 1. So again, we need to try to get our radical by itself. The positive 4 stops me from having the radical by itself, so I need to take that positive 4 and move it to the other side by making it negative 4. So now I have square root of x equals negative 5. And it looks like I am ready to apply the square to each side, but I shouldn't. And here is why. The square root of x, or square root of anything, the square root, should not equal to a negative number. this number here should be positive for you to be able to solve it. That also applies to fourth roots, sixth roots, and any root with an even index. If this root was a cubed root, let's say cubed root of x equals -5, this is fine. Cubed root, fifth root, any odd index root is fine to be equal to a negative number. With the square root or any even index root, you shouldn't have it equal to a negative number. So this is fine and you can continue solving it. This, however, has no solution. A solution is an empty set. This is it. This is how you solve radical equations.